I think you may even have this on your formula booklet. Does anyone want the formula booklet here? This f dash x. So f dash x, you see there's an apostrophe there. Please note that doesn't say f minus 1. Okay, don't get confused with them. So when it's an apostrophe, it's f dash x. It's another way of indicating it's the gradient. So we've got that or dy dx. These are both equivalent forms. And so you're looking for, there's a calculus page that say first principles. Alright, so at the top of your formula booklets you actually have this. So it's just fancy way we would write lim as h approaches 0. And remember it was f of x plus h minus f of x over h. And that's what we're going to use each time we use this first principles. But it is in your formula booklet. So let's maybe put a star here. On the top of the calculus page. Alright, so as I said, this is called limit theory or finding the gradient function. Oops, spelling error. From first principles. So if we talked about first principles, this is what you're using. Alright, so let's use it now with this expression. Okay, so it's going to be very similar. So we're going to write lim h approaches 0. What are we going to write first of all? F of, we don't need to write the formula. What are we going to write?
X cubed.
Not x cubed yet.
F of x.
No, not f of x cubed.
Isn't it x plus h cubed?
Nice people, x plus h cubed. Excellent. Because the function is cubing it, cubing x. Okay, so remember, if we're finding f of x plus h, we're going to do whatever we would have done to x, but this time to x plus h. Okay, so that's going to be x plus h cubed minus x cubed, yeah, over h. Because remember the formula is f of x plus h. Alright, so now we need to expand 3 brackets. So this is going to test your ability. Okay, so we're going to have 3 brackets here. Does anyone remember binomial expansion? Remember we did the binomial theory? Do you remember that? When we had a plus b to the power n?
Yes.
Do you remember that? So when we had to the power 3, do you remember which row of Pascal's triangle were we looking at?
4.
It's equally actually the 4th one down, because remember the top one is class as 0. Does anyone remember the numbers?
1, 3, 1.
Nice, check you lot out, okay? So the 1, 3, 3, 1. So let's see if we can do this without actually using algebra. See if we can remember the binomial expansion. So we're going to have 1, and then what was the rule? The first term starts up as the power, yes? So my first term is x, so I'm going to have x cubed.
Oh, but in h 0.
And h is 0, yes, so that I'm not going to write that. Or do you want to write it?
No.
Okay, then plus, remember that it's a plus in between, and then the next number is going to be 3, because that's the next Pascal's triangle number.
X squared.
So that's going to be x squared, and h comes into play. Do you remember this? Do you want me to write the h0 here? So this is 1, x cubed h0. And then this is 3x squared h1. Do you remember? Because the 2 and the 1 have to add up to give our power. And then the next term is going to be what? Ali, see if you can do it.
3x h squared.
Nice. Plus, and what's our last one going to be?
X plus h.
Say again?
X plus h squared.
No x now. It's going to be, because it started at 3, 2, 1, so it's going to now go 0. So our final number is the 1. And then x is going to be the power 0, h will be the power 3. You heard that bit?
That's what I said.
I had pluses.
No. Sorry. Wait. 1x0, wouldn't it just be 1?
Yeah, I mean, I'm trying to be consistent with the rules. Obviously, some of these things are going to simplify. All right, so this first. Oh, I lost something. Tell me, I lost something. Minus x cubed, I forgot it, sorry. Because remember, this stuff here was just these brackets. All right, let's do a little bit of simplification. So obviously 1x cubed h0 is just x cubed. 3x squared h, which is 3x squared h. Plus 3x h squared plus h cubed minus x cubed. Okay, so I've just got rid of my powers of 0 because they're just 1s, and I didn't bother writing my 1s anymore.
Okay,
What do we see that can cross out?
x cubed figure x.
Good, because these two, and you will find that happens all the time. Or a lot of the time, depending on which ones you're doing, but most of the ones you'll be doing this. And then what did we do last time we did this?
Also h to the front.
Good, so we're factorizing. We're going to bring h to the front because we can see that these three terms here still have a common factor of h. So I'm going to bring h to the front. So this first term is going to now be just 3x squared. The second term is going to be 3xh. And then it's going to be plus h squared. Okay, so what I've done is I've factorized, I've brought out h, just h, because that's the highest number I can bring out. And now the h is cancelled out. And again, that's what you're trying to do every single time. You don't want an h on the bottom. Tell me why we don't want an h on the bottom. Because what was our next step? What do we now say? We now say that h is 0. And we know if we have h on the bottom, it's going to cause us an issue. Because we can't have something divided by 0. Okay, so the limit as h approaches 0 now means that this expression here is going to be 3x squared plus 3x times 0 plus 0 squared. What does that then simplify to give? Just 3x squared. Why did that second term disappear, Olivia? Why would this term here have disappeared? Yeah, because we're times by 0. Okay. So you can't